What we'd like to do here is get used to the idea of thinking of an angle as being a distance around this unit circle to get to a point, rather than the number of degrees it takes to actually get to a point. Now we need some basic things to do this, and then we'll try to do a bunch of examples. Remember that the circumference formula for a circle is 2 pi r, but the unit circle has radius 1, so this is just going to be 2 pi. And what that's going to tell us is to go all the way around the circle is about 6.28. I think we'll probably only ever use about 6.3-ish. Half of that is pi, and I'm just going to try to think about that as being about 3.14. Half of that is 1.57. That gets us to the top. A quarter plus a half of the circle is going to give us 4.71, and that gives us the number on the bottom. Now this isn't going to be enough to actually help us estimate things, so we need some other landmark distances besides those four. The top is about 1.6. The very beginning is about 0. We're going counterclockwise just like we do with degrees. So half of that is about 0.8. If I go halfway into the second quadrant, I have my 1.6 plus my 0.8. That gets me to about 2.4. That's about 3.1. That's about 4.7. If I add 8 to this, I get about 3.9. And finally, I take my 4.7, I add half, which is a 0.8. I get about 5.5. These need to be memorized because we want to use them like crazy to estimate different kinds of things. Let me give 3 or 4 different examples. If someone says, I want to estimate the sine, say, of 2.2, just nice and quick, what do we know? We know the top is about 1.6, 3/4 over here is 2.4, so half of that is actually at 2, right? Now halfway between that and that is about 2.2, and so that actually gets us to the right spot, and then we want the y-coordinate at that point, which looks about 0.8, because the sine is about 0.8. And why? If I want to estimate something like, I don't know, the cosine of 4.3, I know that 3.9 is here, 4.7 is here, 4.3 is exactly pretty much in the middle, and we would want the x-coordinate of that. The x-coordinate of that is about there. That looks about negative 0.4-ish, 0.5-ish if you want to do it that way. How about one more? Just so we can practice something, if I want to say, I want to estimate the sine of, say, 1.5. Well, I know the top is about 1.57, so we're almost there, and we get really, really close, and we want the y-coordinate. It looks about 1. We never guess a number that's wrong. Let's just call it 0.99. The idea that we're trying to demonstrate here is if someone gives us a distance between 0 and 6.3, we can actually get very close just by using the little landmark numbers we have and trying to manipulate them. Now this can go backwards. Let's try to put these in red. If someone says, I want this distance right there, and I'll call it the red distance, and we use, for distances around the unit circle, we use the letter T. Now what do I want? I know that this is about 0.8. I know that this is about 1.6. I know that halfway between them is 1.2, so to get the red dot is almost exactly 1.0. Let's try this again. If I want to say get to here, I just want to know what distance I have to go. I know it's at least 3.1. Halfway between 3.1 and 3.9 is 3.5, and that gets me just about there. And you can see that the distance we're after is about halfway between 3.5 and the 3.9, and so we can get 3.7 pretty quickly for the second dot. How about a third dot? Just so we have this, the 5.5 is right there, so it kind of sticks us there. How about how far it is to get to that dot? Yes, we know that 4.7 gets us to the bottom of the circle. We know 5.5 gets us another in the middle of this quadrant. Halfway between 4.7 and 5.5 is about 5.1. That makes this about 4.9. That makes this almost exactly 5.0. We are going to need that kind of intuition and facility just in order to be able to get good estimates of solutions of trig functions and to estimate trig values. The video after this uses Desmos to try to get much more precise values than this. But what we're doing here with this video, just getting good, quick, rough estimates, is by far the most important thing you'll learn to use when you're doing trig.